Hi there. This video is for section 1.5, finding values of trig functions without using technology. Now, this is a technology active course. We're going to be using technology quite a bit in calculus, but there are basic computations that we should be able to do without having to rely on technology. I guess the analogy might be if you had to reach for a calculator every time you did the square root, or every time you multiplied, numbers together, it would be okay. You would certainly get the answer, but it would just be that much more difficult to stay focused on what you're trying to learn. You're trying to learn calculus, so we want to try to make things that are easily computable, and not have to interrupt that by reaching for a device every time. This is also an opportunity to review what these trig functions are. So we can only find exact values of trig functions at particular angles, at particular values. They are typically 0 degrees, 30 degrees, 45 degrees, 90 degrees, and anything which is symmetric to one of those 5 angles. It's very handy to have a chart if you are a little bit rusty on your trigonometry. It might be nice to have something as a reminder. Here are the 5 angles, 0, 30, 45, 60, and 90, and their radian equivalents, and the cosine and the sine of each. So let me just be clear. Cosine is not adjacent over hypotenuse, although that is certainly true in a very simplified situation. When you have a very simple triangle in the first quadrant, yes, cosine can be written as adjacent over hypotenuse, but that will not work for calculus. Cosine is an x value. It's specifically the x value of a point on a unit circle that's found by rotating a certain number of degrees specified from the x-axis. So that's kind of a mouthful, but cosine is the x value of a point on a circle, is what we really need to be able to understand. And that's how we can get these values for cosine and sine. Sine, by the way, is the y value of the point on the unit circle, similar to the cosine, which is the x value. By the way, I can approximate pretty much any cosine and sine just by drawing a unit circle. Maybe I'll show you that as well. But for the most part, in your calculus book, they use the recognizable common angles 0, 30, 45, 60, and 90, or something symmetrically equivalent to those, so that you won't necessarily have to approximate or necessarily use a calculator. I typically use a calculator when the angles get funky and I'm a little lazy and don't want to approximate, but it's nice to be able to do that nonetheless. All right, so you can see that for 0 degrees, the cosine has a value of 1. Let me show you why that's the case. So once again, the definition of sine and cosine have to do with a circle, specifically a unit circle. So let me draw a circle. And what do we mean by unit circle? Well, a unit circle is very specific. First of all, the circle is centered on the XY axis. And this point right out here is where x is equal to 1. So it's a very small circle, actually. This is -1. This is y is 1, and y is -1. If you wanted to write y is -2, it would be down here at -2. X being +2 would be to the right here of the screen. I had to make the screen a little bit bigger, but 2 would be over here somewhere. 1, 2, 3, -1, -2, -3. I guess I can draw a -2 somewhere over here. We don't really need the 2s and 3s and stuff. I'm just trying to help you visualize that this is a circle centered at the origin with size 1, radius 1. The thing inside the cosine sign, this is a function, so it's like f of x, cosine of 0, right? The thing inside the parentheses is the angle. So I'm saying cosine of 0. The angle is 0. I'm looking for the x value on the circle with an angle of 0, and we always start from the x-axis. So here's the circle in blue. If I start from the x-axis, which is right here, and go 0 degrees, I'm right there. So what is the x value there? Well, it's 1. That's why the cosine of 0 is equal to 1. What's the cosine of 90 degrees? Well, I have to rotate 90 degrees. We rotate counterclockwise because it goes into the positive direction instead of the negative direction. So we're rotating 90 degrees. 90 degrees is a right angle. So if we rotate 90 degrees, we end up right up here. What is the x value there? It's actually not 1. If you're thinking 1, you're in the right track, but 1 is the y value. Cosine measures the x value. So the x value there is 0. If you're thinking 1, you have the right answer to the sine of 90 degrees. Sine of 90 degrees is equal to 1. It's the y value. Cosine is the x value. Cosine of 90 degrees is 0 because the point here at 90-degree rotation has an x value of 0. Now in calculus, we actually measure angles not in degrees, we measure them in radians. It basically is to make all our calculus formulas way easier. If you try to do calculus using degrees, the formulas, especially the trigonometric formulas, are very complicated, where if you use radians, it's all very, very simple. So with a little bit of practice, you can become good at radians as well, but you'll be seeing it all throughout your textbook. It's a standard way of measuring angles. So how do we measure radians? Well, all the way around a circle is 360 degrees. And all the way around a circle is 2 pi radians. So we have this equivalent of 2 pi radians is equal to 360 degrees. I'll use that little degree symbol there. Moving up here. Guess over here. Okay. You can actually divide this out a little bit. I know the math people love simplifying this type of equation. So they typically write pi radians is equal to 180 degrees. And by the way, that represents that if I go halfway around the circle, halfway around the circle, that's 180 degrees. That would be half of 2 pi, which is pi radians. All right, so the one last thing is that we abbreviate things. Instead of saying degrees, we use DEG or this little circle symbol for degrees. The abbreviation for radians could be RAD or some other abbreviation. Or if they leave off any unit whatsoever, the default is radians. Remember, in calculus, we pretty much measure everything by radians. So if they give you an angle and there's no degree symbol, see there's no degree symbol here, no word, no DEG or anything like that, it's assumed that it's a radian measurement. So that's a radian measurement. All right, so what is cosine pi over 2? Well, you have to find the angle pi over 2. If pi is 180 degrees, like we just said, then half of that is 90 degrees. So cosine of pi over 2 is the same as cosine 90 degrees, because pi over 2 in terms of radians is the same as 90 degrees in terms of degrees. So what is cosine of pi over 2? That's the same thing as cosine of 90, which we determined was 0, because at this point at 90 degrees, or pi over 2 radians, the x value is 0. What about sine pi over 2? Well, pi over 2 is 90 degrees. It's a quarter rotation. And as we discussed before, sine is just the y value. And that is the answer 1 for this point up right here. For this point right here, if you were to write out the coordinate system, it's an x value of 0, a y value of 1. And so the y value is the sine. Sometimes people write the coordinate system as cosine of an angle and sine of the angle, because remember the x value is cosine and the y value is sine. All right, so what is sine pi over 2? The answer is 1. All right, so if you haven't paused the video, this is a great time to do so. See if you can find some of the following answers. Now, I know some of those are tricky because they go beyond what I demonstrated, but hopefully you had a chance to think about them and try a few. Let me show you some answers to ENF, and make sure to feel free to pause the video at any time and try some others if you didn't get all the way through. All right, sine pi, we have to locate pi radians. Pi radians, as I mentioned before, is a half rotation, 180 degrees. And so that's the point right over here. That's the point that we get after rotating, the point on the circle that we get after rotating pi radians or 180 degrees. So the sine measures the y value there. What is the y value at that point? It is 0. And what is the x value at that point? That's the cosine of pi. Or this is the point right here. The x value is -1. Right? It's literally the x and y value. This point right here, the coordinates as an x value of -1 and a y value of 0. That's why the cosine is -1 and the y value or the sine is 0. All right, then we have sine of pi over 6. Pi over 6 is 30 degrees. So 90 degrees is a quarter rotation. We'd have to break that up into 3 pieces for 30 degrees. If you haven't memorized this chart, like memorizing your multiplication tables, you might want to refer to it every now and then just to help you remember what's going on. My screen has gone blank. There we go. So 30 degrees right here, pi over 6. That's the number of radians. It has a cosine value of √3/2 and a sine value of 1/2. Come on back, screen. So this particular problem, when it kind of resolves in, oh, I think I can trick it by moving it a little bit, maybe. Yeah, there we go. All right. So this particular problem, it says sine pi over 6, which is the y value, which if you look on the chart or if you look at the y value of this point, it's a y value of 1/2. And how many degrees is pi over 6? Well, remember pi is 180 degrees. So if you take a sixth of that, that's 30 degrees. Take 180, divide by 6, you get 30 degrees. And the y value at 30 degrees, or pi over 6 is 1/2. All right, sine 5 pi over 6. Well, 6 pi over 6 is the same thing as pi. So 6 pi over 6 is just half a rotation. And 5 pi over 6 is just, well, pi over 6 shy of 6 pi over 6. So this right here is your 5 pi over 6. It's 1/6 pi from 180 degrees from pi radians. And so this is where we use the symmetry of the circle. Circle is perfectly symmetrical. So if this y value was 1/2, then this y value is also 1/2 because of symmetry. What about 7 pi over 6? Well, 7 pi over 6 goes a little bit beyond pi. This is where 7 pi over 6 is. Again, we have symmetry, right? It's still the same pi over 6 angle away from the x-axis, but so it should have the same y value. But in this particular case, we're below the x-axis, so we have negative y values. So by symmetry, we know this has to be -1/2. All right, so those are some examples of finding trig values. It's also be able to important to go backwards. So cosine inverse, what does an inverse function do? Inverse functions reverse the inputs and outputs. It reverses the roles of x and y. So before, let me scroll up a little bit, we put an angle into the parentheses, and what we got out was an x value. For cosine, at least, we got an x value. For sine, we got a y value. All right, so you put in an angle, get out an x value. So the inverse function is going to switch that. We put in an x value and we get out an angle, or we put in a y value if it's sine and get out an angle. So right here, this 0 is an x value. Instead of putting in an angle, we're putting in an x value, and what we're getting out is the angle. So what we get out here is some angle. But what's the angle? It's the angle where the x value is 0. So we have to look now on our circle, and we have to find out what x is 0. Well, this is where x equals 0 right here. So what is the angle? Well, if I go up here, the angle is 90 degrees, or pi over 2. But there's also an angle down here, which is 3 pi over 2. So for inverses, sometimes you get more than one answer, which is going to be kind of a little bit of a problem. In fact, it's a little bit worse than I mentioned right here, because the way we measure angles is rotation. We can rotate all the way around the circle. Like I can rotate all the way around, which is 360 degrees or 2 pi radians, and another quarter turn. So I can go 360 plus another 90, which would be 450, or I can go 2 pi and another pi over 2, which is 5 pi over 2. That also has an x value of 0 because 5 pi over 2 ends up exactly right here. I go all around and here, and that ends up being where 5 pi over 2 is, and the x value at 5 pi over 2 is still 0. And there's many, many, many more. So the math people decided, hey, you know what? Let's decide that there's like one answer that we're going to default to if we need to. So the default answer is this one in the first quadrant. So if you use a calculator, it will give you pi over 2 as the default answer. But there are many, many other answers. And in some situations, pi over 2 won't actually check in our problem, but 3 pi over 2 will. So you have to be careful that there are multiple solutions. There's one of a default, but some situations you'll need to check the others. All right, sine inverse of 0. So sine is a relationship talking about points on a circle and the y value. So this thing right in here has got to be the y value. And we're looking for the angle again. So when you have a y value of 0, y is vertical. We're either here, that's where y value is 0, or here. So y value is 0 has an angle of 0, or an angle of pi, or some others, 2 pi, 3 pi, etc. But we're going to choose the one in the first quadrant here, or at least the one on the axis, to be the default. So we're going to say sine inverse of 0 is 0, unless we have some reason to say that we need to write out multiple solutions. Sine inverse of 1 says the y value is 1. So looking at our circle, y value is the vertical axis. Here's where the y value is 1. So what's the angle there? Well, the angle is pi over 2, 90 degrees if you're doing degrees, pi over 2 if you're doing radians. You can actually go all around the circle. You can do 2 pi plus pi over 2 and get 5 pi over 2 if you want. Or you can do another 2 pi around and get 9 pi over 2. You can keep going around and around and around. But once again, we have a default answer. So the default right here is the first one, pi over 2. And lastly, cosine inverse of 1, we have a y value of, second to lastly, cosine inverse of 1, we have an x value of 1. So here's where the x value is 1. What's the angle there? The angle is 0. Pi doesn't work because the x value is -1, but we can do a full circle rotation and get to 2 pi. That also works. Or 4 pi, which is 2 rotations. Once again, the default answer is just doesn't look right. It's 0. This is supposed to say 0. All right, now the last one, sine inverse of 1/2. This is the y value. We're looking for the angle. You may remember from a previous problem, we did sine of pi over 6 is 1/2, which meant at an angle of pi over 6, which was 30 degrees, the y value was 1/2. So if the y value is 1/2, what is the angle? Oh, okay, well, it's pi over 6, 30 degrees. Of course, we can also get a symmetric angle. We saw before that 5 pi over 6 is exactly symmetrical to 1 pi over 6, has the exact same y value. So we get 5 pi over 6. 7 pi over 6 had a negative because it was down there, so we didn't include that. Of course, there are more and more and more, but we'll take the first one as our default answer for the inverse sine of 1/2. All right, so this lecture was trying to help you understand basic ideas of what trigonometry measures, doing some practice problems, finding sine and cosine of some simple angles without using technology. So hopefully that was helpful. Please let me know if you have any questions, and hope you have an enjoyable day.